Hello, good morning. My name is Armando Ramalho. I'm from the Polytechnic of Castelo Branco, and I will present the work evaluation of the structural strength of anisotropic PLA components manufactured by 3D printing. Here is a brief outline of my presentation. The fused filament fabrication, a material extrusion process used in low-cost 3D printing, is one of the most affordable manufacturing process for producing complex geometric components. The finite element analysis is the best method to evaluate the mechanical behavior of complex geometric parts obtained in 3D printing. The layer-by-layer slicing sequence of 3D printing is prone to introduce anisotropy into the materials. In this communication, it is evaluated the structural strength of an anisotropic PLA bushing manufactured by 3D printing. It is evaluated the structural strength of a bushing that belongs to a hinge drawer support and is subjected to the in-service loading. The material properties of the anisotropic PLA are obtained in literature. The structural strength are evaluated using the maximum stress, the Tsai-Hill and the Hoffman-Taylor criteria. A previous preliminary finite element model developed by the authors is updated and implemented in Mark software to deal with the used failure criteria. As I said, the component analyzed in the study is the batching of hinged drawer support. The drawer and its content have a design weight of 20 kilograms. The parts of the hinged drawer support are made in ABS and manufactured by injection. A preliminary reverse engineering bushing design was being done in previous work. Here is the main inputs of this work. And at the end are the main manufacturing parameters for the bushing. In order to account the anisotropy in the failure of the bushing, theories from the composite materials were used. Each layer of the manufacturing process is treated as a lamina, and the stacking of these layers form an orthotropic material. Three criteria were considered in the study. The maximum stress criterion considers that the material fails when the stress exceeds the respective allowable. 6 failure index are defined, each one related to one condition of failure. The equations used to compute the failure index are the following. The Tsai-Hill criterion considers that the orthotropic material fails when the failure index exceeds 1, and it's assumed that the tensile and compressive behavior of material are identical. The failure indexes are computed using this equation. The Hoffman criterion is similar to the Tsai-Hill, but allow unequal maximum stresses in tension and compression. The failure index is done by this equation. All the numerical simulations were performed in a computer running a simple Windows 10 with the processor Intel Core i7 with 16 gigabytes RAM. and the finite element model was developed in the finite element software Mark 2021. Here is the main inputs for the numerical model. And the orientation of the mesh elements was considered for the anisotropic axis of the material behavior. The simulation used the simulation used an axisymmetric mesh and structured mesh. This is the main characteristics of the mesh. Here we have the orientation, the local orientation of the axis of the elements. Here we have the material properties used to simulate the material behavior of the PLA. As boundary conditions, the displacements were restricted at the outer surface of the support. The transverse, in red, here. The transverse displacement were restricted at the hand section of the screw, in blue. Contact conditions were considered between the bushing and the screw, and the bushing and the support, here. An algorithm of segment-to-segment contact was adopted. For friction, it was considered the Coulomb bilinear friction model. An initial clamp of 20 newtons was applied in the axial direction at the end section of the screw. A vertical load of 100 newtons actuates in the direction 3 at the outer surface of the bushing through a link in red. Here are the results obtained for the index failures field for the maximum stress criterion. I think is that the higher values occurs in the contact between the bushing and the head of the screw. For all these failure index. Here are the remain failure indexes for the maximum stress criterion. This picture shows the failure index obtained for the SAIL criterion. The maximum value for the failure index occurs in the same position. And this is the one for the Hoffman criterion. From the presented results, one can assure the structural safety of the 3D printed bushing under the in-service loading. All the failure indexes of the used failure criterion are below the maximum values admissible. The more critical one occurs for the failure index 4 in the maximum stress criterion at the screw head interface. All the other criteria have their maximum absolute values at the same position. The mechanical properties obtained in the literature for the PLA reveals an ultimate tensile strain below 4.5% and the compressive strength substantial superior to the tensile one. For this material, it is recommended to use the maximum stress criterion or alternatively the Hoffman one. As conclusion, through the study, it was possible to manufacture by 3D printing a bushing that resists to the in-service load conditions. Is a project with confidence. The usefulness of numerical finite element method with the failure criteria extensively used in composite materials in the structural design of parts manufactured by 3D printing was demonstrated. In the study, it is recommended to use the maximum stress criterion or alternatively the Hoffman one in the structural design of PLA parts manufactured by 3D printing. Thank you.
Thank you, Armando, for this deep insight into simulation work. Are there any questions from the audience? Have one. It was not clear for me if you validated the simulation work with empirical parts.
Yes, yes, we have printed the bushing, and the bushing is put in service, and that resists to the in-service loads.
There's no significant deviation from the values you expected from simulation.
In this work, there are a simple problem that is the validation of the material properties. But in the afternoon, we will present a work in which we obtain these properties, these anisotropic mechanical properties. Okay.